Let's start with sensible heating and cooling. In both cases, the dry bulb temperature changes, but the humidity ratio stays constant. In other words, no moisture is added or removed. This happens when air passes over a heating coil or a cooling coil without any condensation or evaporation. We calculate the amount of heat transfer with this equation. Q equals to mass flow rate multiplied by change in a specific enthalpy. And with some approximations, which we will not go into here, we can express enthalpy as Cp times delta T, leading to a second simplified version of the equation. Now, in sensible heating or cooling, there's no change in the air's moisture content. Since the heat contribution from the water vapor is relatively small, we can ignore it in this case and focus just on the dry air's heat change. That lets us simplify equation even more, and these simplified forms are actually very useful, especially because they let us calculate heat using just volumetric airflow rate and temperature difference, which we can measure directly using HVAC sensors. Try to memorize these two equations. You'll use them a lot both in this course and later in your work. This video is part of the HVAC Fundamentals course on AEC Learn. If you found this helpful and want to become an HVAC engineer, visit aeclearn.com. And don't forget to subscribe to the AEC Learn channel on YouTube.